So we've done one example here. We've done another one here. Okay, yeah. Fine, so let's take a look at something slightly different, and we are going to be on question. What question are we on now? 3, so let's go on 4. And we're integrating x squared over x plus 3 dx, and we need to use substitution, and our substitution is u equals x plus 3. First step, you find du, so du by dx is equal to 1. The plus 3 disappears and x to the 1 becomes x to the 0, which is 1. So let's go back here and let's integrate again. So we're integrating. Let's put everything in terms of u. X squared, right? Okay, we're going to need to do a little bit of manipulation here. So we are going to go, let's find x and then square it. So in this case, u minus 3 is equal to x. U minus 3 from both sides. So x is u minus 3. So in this case, for x squared, it will be u minus 3 all squared. And then the denominator is x plus 3, which is u. du. Let's expand the brackets at the top. So u minus 3 all squared is the same as u minus 3 multiplied by u minus 3. So you can do FOIL, you can use any method you have been taught at school. And you will end up with u squared minus 6u plus 9. When you expand those, so you end up with u squared. There's the plus 9. 3u minus 3u minus another 3u, that's your minus 6u. Okay, divided by u du. Let's do a little bit of simplification before we integrate to make our lives easy. Let's go u squared divided by u minus 6u divided by u plus 9 divided by u du. Let's simplify further. I can go u squared divided by u is u minus 6. U divided by u will disappear. Plus, let's leave 9 over u alone. du. Okay, integration. It's all now in terms of u. It's very simple, straightforward. Now we can integrate. When we integrate, we increase the power, divide by the new power. So let's increase the power of u. It's u to the 1, increase the 1, u squared divided by 2, minus 6, and there is an invisible u here, which is u to the 0. Increase the power, the 0 will become 1, so 6u plus. This is the same as 9 multiplied by 1 over u. 9 will integrate into 9. It's a number, it's a constant, we leave it alone. And 1 over u integrates to ln mod of u plus c. 1 over u integrates to ln u. Okay, so let's rub these off. And let's then, final step is to put u back into x, change u into x. U was x plus 3 at the start of the question. We've let it, so x plus 3 whole squared over 2 minus 6 x plus 3 plus 9 ln mod of x plus 3 plus c. And that is the integration using substitution. Okay. Let's take a look at a different question. What number are we on now? 5. Okay, let's go 5. And this time I am integrating cos squared x sine cubed x dx. Excuse me. And in this case, we are going to let u equals cos x. Du by dx is, so let's remember, sine cos minus sine minus cos. We differentiate this way, we integrate the other way. So so cos differentiates into minus sine. So I'm going to have minus sine x. Okay, let's go back to my question and let's try the idea of integration by substitution is to substitute, basically. Do what it says on the tin, where we are substituting. And we substitute everything in terms of u, and then differentiate, and then and then integrate. Okay, let's take a look here. So I'm integrating cos squared. Cos squared is simple. I think I'm going to leave it as cos squared for now. Cos squared x for now. Sine cubed. Now with sine cubed, I am going to go sine squared x multiplied by sine x dx, and you'll find why in a minute. Sine cubed is sine squared times sine. X cubed is x times x times x, or x squared times x. So I'm just breaking it down a little bit. Okay, equals. I'm integrating. I think I can go, instead of the sine squared, I can go 1 minus cos squared. Remember? Sine squared x plus cos squared x equals 1. So instead of sine squared, I can go 1 minus cos squared. So this is what I'm doing here. So cos squared x, 1 minus cos squared x times sine x dx. Now let's try and substitute. Cos squared is straightforward. I can go u squared. So I'm integrating u squared. Right, 1 minus cos squared, again, another straightforward one. It's 1 minus u squared. I know cos squared is u, cos is u, so cos squared is u squared. Sine x dx. Now, what is sine x dx? Minus du. So I can put a minus somewhere here, inside or outside the bracket the integration. And instead of sine x dx, in fact, I can put du minus du and stick the minus anywhere. Doesn't really matter. You can kick it out of the integration. It's perfectly fine. Right. Have I got it all in terms of u? Yes, I have. Brilliant. Just a little bit of simplification and then I can integrate. So let's keep the minus out. And then I'm integrating. Now I'm expanding the brackets here. So u squared minus u to the 4 du. Easy peasy, all in terms of u. The integration should be straightforward. Leave the minus alone. Bracket. Increase the power. When you integrate, you increase the power. Divide by the new power. Increase the u squared into u cubed divided by 3 minus u to the 4. Increase the 4. U to the 5 over 5 plus c. One final step is to put the x back. So we can multiply. I'm in two minds whether to multiply the minus by the bracket or not. Let's leave it. It doesn't really matter. So u cubed is minus cos cubed x over 3 minus cos to the 5x over 5 plus c. We can choose to multiply the minus, so I can go cos to the 5x over 5 plus, actually minus cos cubed x over 3 plus c. Actually, all I did in the last step, you didn't have to do it. All I did is in the last step is to multiply the minus by the bracket and get the positive to be at the front. It doesn't really matter. Okay, brilliant. So that's question 5. Let's take a look at question 6. I'm integrating sine squared to x, tan to x, dx. And in this case, I am asked to use u as, or let u as cos 2x. Okay, the idea of integration by substitution is to differentiate u and then put everything in terms of u. Right, so du by dx. Let's remind ourselves, this is sine cos minus sine minus cos, differentiate this way. So cos differentiates into minus sine. So I know there will be a minus sine to x there, but it's kx. So it's going to be minus 2 or minus k sine kx or 2x. K is 2. So minus 2 sine 2x. Right? Let's now substitute everything to the best of our ability in terms of u. Now, before we do that, can we make things simple? Let's think about it. Sine squared is, I know that sine squared will be 1 minus cos squared to x. Right? I know that 1 minus cos squared to x, yeah. Okay, I also know that tan 2x is the same as tan is sine over cos, so sine 2x over cos 2x dx. Okay, just trying to simplify things and make things simple for myself when I start substituting. Equals integration. 1 minus cos squared, this is very straightforward, it will be 1 minus u squared, easy peasy. Cos 2x is u, and therefore cos squared 2x is u squared. Straightforward. Now, sine 2x. Let's take a look at this one. What is sine 2x dx? What is sine 2x dx? Okay, I can go du, I can change it to du over minus 2. Do you all agree? Sine 2x dx should be equal to du divided by minus 2. Now, 1 over cos 2x is the same as 1 over u. This is 1 over cos 2x. There's a 1 here. So 1 over cos 2x is 1 over u. And sine 2x dx is du over 2. Okay, let's make things simple and then we will be ready to integrate. Right, okay. Minus a half, I'm going to kick the minus a half out of the integration. Just making life easy. And I'm going to divide by u. So 1 over u minus u squared over u du. right? Again, simplify more, make things simple for yourself. So minus a half, and then integrating 1 over u, and u squared divided by u is minus u du. Now let's integrate. I've got it all in terms of u. I'm ready to integrate. So equals minus a half. 1 over u integrates into ln mod of u minus u. When you integrate, you increase the power, divide by the new power, plus c. One final last step is to put u back in terms of x, and u is cos 2x. So let's go back and put, whenever we find a u, we replace it by cos 2x. So minus a half ln cos 2x minus cos 2x over 2 cos squared 2x, yeah, plus c. I can choose to multiply the half out or the minus sign out, but there's no need to. I can multiply the minus a half by it, but you don't have